Hey everyone, Nazir and welcome in part two of building like a Rust CLI application. We call this application as MiniGrep, and it's simply querying a file and returning all the lines that contains the query string. And as I mentioned on the previous one, or in the first part, I'm using a new approach, and I linked the video on the first part. This approach like meant to build everything, having a clear idea of the problem and solving it with your code. And then once you have everything up and running, you go and refine this code and make it more cleaner or more architectured. And this is what we are going to do in this part two and also on the upcoming ports. Let me go to my Rust directory and then the demos and MiniGrep and open my code editor. Yeah, let me look myself a bit up. Okay, if you remember from part one, we checked all of those tasks, and today we will have like a new set of tasks to accomplish by the end of this video, part two. First task, we need to ask ourselves or brainstorm together why we are refactoring a working code, because like this code is working and it solves the problem that we want. Second thing, we will refactor the file path and query into their own entity. Then we will add simple validation and error handling. At the end of the day, everything should be working fine. You can say this is like backward compatible. And this is our checklist for today. If you watch the first part and end up with a code like this, like mine, so you'll notice that one big function called main doing everything. Also, the program can panic because we are not checking on different aspects. For example, here we are fetching the second argument, here we are fetching the third argument. But if you pass just one argument to application, the application will crash immediately without like proper error to the end user or the one who is going to implement this library into their applications. So let me answer why we are refactoring a working code. Because like here, everything in one place. This is a big chunk of code. It's hard to be maintained, hard to be tested, hard to scale as well. So, and also one function doing everything. This is violates the principle of like separation of concerns. So for those reasons, we are going to refactor this code, and this is a lesson that we are like learning and doing it on day to day. Like every time you find like a function that is doing so many things, feel free to break it into small chunks, and those small chunks can do small functions, and each small part can be tested with proper unit testing. This will make your life easier, will make your code maintainable and testable, and also can scale in a good way. So I think this answers the first part, why we are refactoring big code. Second part is like refactoring file path and query into their own entity. If we logically think about it for a minute or two, that we will find that the file path and the query are related to the same entity or the same family. They group something together, they do the same thing. So it doesn't make any sense to have them in separate variables. So we need to group them. So the simplest way of doing this is creating a new struct. And both are configurations to the process that will comes after. Like it's the file path defining the file path and the query defining the string that will be searched within the file. So it make more sense to have them into or under one entity. To do this, we'll go to the live RS. I remove the default stuff. I just keep those for the future. And then here I will create a new struct. For sure it will be a public struct. I will call it config. And here I will define file path. It will be of type string. And I'll define a query, and as well this is of type string. As I mentioned before, I'm inspiring this tutorial from the Rust learning language, but with a bit of differences and updates I love to share with you. So here I'm not using public properties from the struct because from my perspective, I like to make things as private as possible and create setters and getters to deal with those properties to avoid any error or any unwanted change in the runtime. This is the way I prefer to write my applications and my APIs. Having something public that is safe and controlled, and then having the stuff that is private. This keeps my application more safe and more or less error prone. So I'll do the implementation for the config, and then I'll create a new associated function. I'll call it new because it's the common name, and it will return an image of self. And here we'll have as well self, and just for a second I'll leave it like that, and then I will enhance this. So the new function in this application context, it will accept a arguments. It will accept the arguments that I received in the main function from the terminal using the standard env as we did on the first part. So, and this will be of type vector, and here string. Okay. And to do this, for the file path, I need like arguments. I will take the first one and then I will clone it. So I will have a copy of this string, not a reference, and store it within my entity. I don't care anyway. Like after that I won't be caring a lot about like the arguments itself. I'll do the same thing here, but I will take the third one and then I will clone it. So I have my instance now ready, and let me make sure that everything works. Now if I removed both of them, and then I will just let me first use MiniGrep, my live, and then here I will define the config, and config will be like let me define MiniGrep as mg just for simplicity, and here I will call like mg config and then new, and I will pass the arguments. Yeah, I think we need to make the new public, so we can call it from here. Yeah, true. So yeah, one more thing, as I mentioned a couple of minutes ago, I'm not allowing accessing my properties directly. So instead of that, we are going to build getters together. So to build a getter, a simple one. So public file path, the same name as the property. It accepts an image of self. It will return a reference to a string, and then it will return like self dot file path, and that's it. Same thing, exact same thing for query. So I'll just change the name. I don't know why it's not. Yeah. Okay, no worries. Let me change this. Query and here query. Okay, so now I have the getters in place. I will go to everywhere I'm using file path. I will just use the config.filepath as a method. Same thing with query, config.query as a method. And this, if we did everything correctly, we need to run the application and make sure it's still running. So I'll say like cargo run with, here I have file.txt and I want to search for the word Nina. So yeah, it's still working and this like analyzes or check the second task. So yeah, a quick recap. We refactored, we grouped together two relatives or two related elements like the file path and the query. We grouped them under the config struct, and then we created an implementation of functions to manipulate and deal with the struct config. We had one for associated, and then we have two getters. Now let's do a bit of enhancements after that. Like here, we enhance it a bit. We now have a cleaner code, but still, if you pass just one argument, if you just pass the file, this will panic. Yeah, as you can see, it panics because here we are assuming all the time we have three arguments. We get the second and the third. So we need a bit of validation here before we move to the third line. So simple validation, if arguments dot length, if the length of arguments is less than, we have two and we have one by default, so it should be less than three. And then here I need to return an error. Yeah, or yeah, I need to return maybe error. I can say like not enough arguments. Yeah, and now we are going to change this. We are going to use the result enum, and here I'm gonna return a config instance, or I'm gonna return here like a string. In the error it will be a string, and I think we need a lifetime because we need to tell Rust, yeah, the string will be here all the time. So yeah, I have an error where it's complaining. I think we need to use the return, and here instead of self I just rewrite this to config, and here I'll wrap it within the OK object, the OK variant, and I think we are good. So what we really did here, we did two things. We enhanced, we added validation, and then we also enhanced the error handling. So we are now giving the upper hand to the caller, which is the main function, to panic or to like write an error to the end user or whatever it wants to do. So this is like error propagation in Rust. We handled the error in a more cleaner way using the result enum, and same time we added a validation. This will require some refactoring on the main because before we were returning just an instance, now we are returning a result enum. So we'll go to the main, and here what's wrong here? Yeah, here it's returning a result. So we need to handle this. To handle this, simple way, you can just use unwrap, and this will panic with the same error message, with the error message that we wrote, instead of like all of those stuff that the end user might not be familiar with. So we just run it one more time. And here, yeah, as you can see, error, that not enough arguments. Instead of unwrap and panicking, we can like push a bit forward to enhance it a bit more using closures. So I can use unwrap or else. Let me just finalize it, and here I can add my closure error, and here I can say like print line error. I will print it to the end user, and I'll use standard process, and here I say like process exit with non-zero code, 1 or 2. So any non-zero means like it exits with an issue. Now let's give it a try with the same thing. Yeah, as you can see, now there's no panics, there is clear message like not enough arguments. We can enhance it as well a bit more. Error, and let's run it. Yeah, error, not enough arguments. Now the user knows that this application is missing some essential arguments and it's breaking. I think this is as well checks this thing, the third task, and yeah, everything should be working fine. Let's test everything, and then I'll pass it file. I remember we had the word YouTube. Yeah, YouTube is good. And we are still reading from this file. I didn't change it from the first episode. And this also checks the fourth task for today. I think that's it for this part 2. So in this part 2, we learned together that how to enhance relative or related variables and then grouping them into a struct. And then we learned how to proper adding validation and error handling, which is known as error propagation in Rust. And finally, we give the upper hand to show the error version to the user and enhance that with using a closure. So in this part 2, we touched on so many aspects. I hope this adds value to you. The third part of this tutorial or next episode, we will touch on like enhancing the reading the file functionality and the searching, returning the results. We separate the reading and the searching into their own functions, and then we will add also error handling. We'll simplify the main function. We'll make it more simpler than this, and then we might have time as well for writing unit tests. If not, we'll do like a fourth part, and then we'll add the unit tests to it. I think that's it for this episode. I hope it adds value to you. And as I mentioned before, I'm still learning Rust. I open for comments, feedback, questions, suggestions, anything to enhance the content and enhance the value, the outcome value. And I hope you have a good day. Thanks. Bye bye.